Hi, welcome back. In the previous episode, we saw that we completed the Neat app application. We tidy up a few things. We created some wildcard routes to handle, to handle erroneous, resource routes, and then we added things like web share, and just basically beautifying our application. So that's the first part of the previous episode. And then on the second part, we deploy the application to a hosting site. And in our case, we use the Firebase, which is what you can see here, right? So you can find the link to this in uh, the GitHub repository. So that's one way of deploying your application. Uh, in this episode, what I will do is I will show you another way of deploying the application by using a container. What we will do in this episode is we will containerize our application. We will create a container. We will use a web server, and then we will bundle our application, our Angular application, into this web server and build a Docker image out of it, build a container image out of it. So in this case, we are using Docker. After we have created the Docker image, we'll push it to the Docker Hub, so that you can examine it. And then what we will also do is we will create a deployment, or we will deploy the application, the container, uh, into a Kubernetes cluster. Okay, so that's essentially what we are going to do in this episode. So so before we start containerizing, let's see what we need to do first, and then we will go on to perform the containerization. So the first step of containerization is we need to build this application. So let's go ahead and build the Angular application. So we'll go ng build for production, like so. The Angular build can take some time, in which case it's actually pretty fast. Uh, Also, I have installed Docker and Kubernetes on my notebook. Again, I do not want to go through the process of of installing Docker and Kubernetes. There are many YouTube videos, and I think that there is really no value in me repeating that. Okay, so we have built our application, and why is okay, and it is under here. So this is our source. Is This is our repository, and we are under front end. And after we have run that command, which is this command, the Angular will create a directory called this, and inside this, you'll find the name of application, which is called front end, and this is the artifact. Okay. Now, what we will do is this: we will bundle this application together with a web server. But before we do that, before we containerize it, we will run. We will. I will show you how to bundle this application first, or how to run this application from a web server. So let's start by, as usual, let's start by creating a branch. Part 16. Okay. Just check. Good. And now I will create a directory called deploy. Right. The first step is I will need to copy the build artifact into this directory. So that will be front end. This front end, and so this is my directory. I will copy it over here. Right. There are many web servers or reverse proxies. You get things like HA proxy or Nginx, whatever. What I found a really good web server that I've been using for quite some time now. It's called Caddy server. It's really cool because it's only a single binary, and you write one configuration file to run this to serve the files. Okay, it's fairly simple. It look it behaves like Nginx. It's got a whole bunch of directives here. Okay, and you can extend it. For this example, I'll be using Caddy. What we do is this: to use Caddy, you create a file called. By the way, I've also installed Caddy. Okay, so that's my Caddy. It's only a single binary. You write a file called Caddy file. That's the default name. And now you say the port that you want. Okay. You can put in your domain name here if there's a domain name. In my case, I'm just going to have that. So that will be localhost. And then now I say root. Okay, the root. So where's the root of my of my of my web application, or so to speak, my HTML files? It is in front end here. And then I'm going to enable the file server. Again, it's part of here, the file server. Okay. Then what I'm going to do is this: I'm going to enable compression. Larger assets, like the Lotte file, what have you, will be gzip. Again, my application is very small. You may have a larger, larger asset. And I will also let's see, what else do I need to do? Okay, let's enable log, and you can say specify different format. I'm going to use the log format. And finally, handle errors. I'll use the handle error. Okay. And then what I'll say is that if there is any error, we will just redirect it to index.html. So any errors, we'll just redirect it back to the index in this page. Okay, that's the file. The way we're going to run this is like this. You go to Caddy, run. Okay, so that's Caddy running. And remember, I'm running on port 8080. Now we can go back to here, the localhost 8080, and you'll notice that the log files start appearing, and this is the Caddy. This is the Caddy file. Just to be sure, because we have got service worker enabled. So let me delete all of this, so that it's not serving from the service worker. And our application, I also delete the two service worker. And now I can reload this, and you notice that this is running. Okay. So storage. So now it's being served from here. Okay. This is what I need, and I need this file. So now it's time to containerize this application. What I'll do is this. We go to Docker Hub, which I have here, and we'll search for Caddy. Slow. Okay, we'll search for Caddy. This is the Caddy. This is the image that we'll be using, and I'm going to use let's see. I'm going to use the version, the latest version. Let's have a look at the packs. These are the packs. I'm just going to use the. I don't want to pull the latest. It's considered bad practice. So what else do is this? Okay, I will pull Caddy 2 to 1. I think if I just pull Caddy 2, that will still work as well. Yep, Caddy 2. Okay, I'll pull Caddy 2. Right. The way this is going to work is like this. I'll write a Docker file. We're going to have two containers. The first container, because rather than copying the files rather than copying the Angular file from my local directory, when I build the container, I would like the build to be self-contained. So what I'm going to do is this. I'll have two containers. One is called the builder container, where we'll build the Angular application. After building the Angular application, we will copy the artifacts, the directory under the dist, the front end directory under the dist directory, over to the caddy container. Okay, so this is what we'll do. The first container, this is to build Angular, our front end application. Okay, and I'm going to use the I'm going to use the Node 14, which is the latest version, and I'll give this a name as, let me call this ng builder. In the second part of the build, I will use this name to copy the artifact from this directory. I'm going to add in some build arguments. Okay, I will say like this. So args, I will say there. I generally like to create a directory where I perform all my operations in there. So the app there is my directory, which is called app. And then let me also do the branch, which we are going to build from. In this case, if you recall, git branch, the latest branch is part 15. I will default this to part 15, and later on you can override this. Okay. So now I will change directory into the app there directory. And now I'm going to clone. I will clone the branch. I'll only clone the single branch from the app. This is called what's that? Neat stack. Okay, so I'll clone a single branch, which is given by the branch argument. Then what I'll do is this. I will now go into that directory, front end, okay, and I will now reinstall the node packages using npm i. After that, I will build by doing node modules bin ng build production. Okay, so if you go back to our front end here, you'll notice that under the node modules bin directory, you will see the ng command here. Okay, so rather than installing it globally, the ng CLI globally, I'll just use whatever is in the node module. So this completes the build. So after this, we will have the artifact, the dist directory, dist directory. So now on to the second part of the container. Okay, so I will do this. I'll now go from caddy, okay, version 2, or if we can caddy version 2, or we can specify. I believe version 2 is linked to 2.11, so I'll just use that. Right. Again, I'm going to copy this over, and then I will define an environment variable which will allow the users to change. I'll call this app pod, and if you recall, the port for caddy file is 8080. So we'll say this is 8080, right? And now I will go 7. Okay, so change into the directory. Now I'm going to add caddy file into the app directory, and now I will copy the artifact that is built here over into this container. So I'll use copy from ng builder, and the directory is under app there. Okay, neat stack front end this front end, and then I'll copy into the current directory called front end. Okay, now I will say expose. I'll define, what is the port that this container exposed. And finally, we'll say entry point caddy. The command that we execute does not run. So that's all the command. Let's run through this again. We start off with a node image, which we have installed node 14. Then we clone a single branch of the source code. We install the node packages. We perform a build. Then onto the second container. This is the deployment container. Think of the first container as the build container. We define the port that caddy is exposing, and this port is important because this one must match our caddy file. I'll copy the caddy file over from a local directory into the image, and finally I will copy copy the artifact from the first container into this directory. And then I say what is the port that this container is exposing, is opening, in our case 8080, and then this is how we run the container. Right, let's go ahead and test this guy first. So I will run this docker. So these are my images. I'll go docker run. The first time I'll just do a trial first, and then the second, and if it's successful, I will create a make file to execute this. I'll just give it any name. Let's call it p1, and then I'll run it from here. The dot is the context. Oh, sorry, not run. Build. So notice that it's now cloning this. Okay, and then after it's cloned this, it is now running the npm install. And this might take some time. So what I'm going to do is I'm going to pause this video, and then I'll return once this is completed. Okay, that is finished building the image. Let's have a look. So we were here the last time. It started performing the installation. So this is the installation. So then it runs the installation, the npm. After running the npm, it then performs the build, and this is the build. So that is completed. Okay, so that's completed. Now that's the intermediate container, the first container, and then we go on to the second container. So the caddy file. We copy the file over from a local directory into the container, and then we copy the artifacts from the first container into the caddy container, and then we are done. So we can have a look at it by going docker images. That's our container here. So let's run this guy and we can test it out. If you recall, it exposes port 8080. You can go docker run -d, run it in a daemon mode or detach mode. We will port map. Let's use port 5000 to 8080. Okay, so this is the external port, and this is the container port. And then I'll give it a name so that it's easy to delete afterwards. And then I'll go. Now I say the name of the image. Okay. Right. So we can go docker ps, and that's the thing that's running. We can go logs -fe. That's the log. And we can now try that. We are exposing port 5000. Right, so this is port 5000. Notice that it's serving from the container. Okay. Okay. So our Docker file is successful. What I'm going to do now is I'm going to create a make file to automate this entire process. So let me kill the Docker image, the container first. And I'll also at the same time remove the Docker image as well. Okay, so let's create a make file. And then I will just do this. I will say version. Let's call this latest. And then I will say branch. Our branch was, what was the branch? What's the branch that we have here? We have branch part 15. I'll show you how to use this afterwards. And the tag here, I'm going to use this as my tag. Sorry, I'm going to use this as my tag. Okay, this is the the log. Okay, so I will create. Generally, is a generally what I like to do is this: when I create an image, I like to tag the image against my Git commit, so I know that which of the from which commit I built this image, and then after that I'll create a more user-friendly version. I will create a more user-friendly tag to this image. So I'll show you what I mean. I'll go like this: shell git ref pass short, and then I'll go branch. Okay, so this one will give me the version. Then I will I need to create a target here. I'll make target. Let's call this Docker. Go Docker build -t. I'm going to push it to the Docker repository, so I need to put my name, my account name. I'm going to call this need stack, and then the first one is going to be the tag. So the first build is going to have the the image is going to be tagged with the commit. Then the second build, well, not the second build, the second one I'm going to tag it with this. Okay, like that. Okay, so let's see how this one works. So if I go make, right, and I want to, again, it's generally a very bad idea to tag your image with the latest. It's always good to have give a version number. So I'll say version. Oh, I haven't used the branch yet. Here we can pass it up, build up, branch goes to dollar branch. Oops. So what this one do is this: we are passing in the branch into here. Okay, so we override this. If we don't specify the branch, if we don't pass in the branch, then default is going to build from part 15. Okay. Otherwise, we can pass it in through the command line like this. So during the build, if you want to, you can change it like this. For example, like this. Part 14. If you want to build part 14. Okay. So in this case, I'm building from part 15, and I'll say the version. I'll tag the version as, instead of using latest, I'll use it as v1. You build application. Now that is done. And the second time is building faster is because we already have the intermediate container. So this is the intermediate container, the part where the Angular is built. And since there is no change, this intermediate container can be reused. And if you notice also that most of the time it's actually spent on this intermediate container. This is my tag. So that's the tag, and this v1 is the user-friendly version that's linked to this. Okay, so notice the image ID are the same, both of them are the same. Now let's just test this first, and then if it's successful, then we can push it to the repository to GitHub. Docker run. Again, I'll just say p. Let's go 5,000 again, and then the port is 8080. I'll just go run v1. So that's running. So we can try it again. 5,000. If we want to, we can reload this. Sorry, not that one. Oh, not cube. Sorry, Docker PS. I didn't give a name, so now do this. Okay, so let's try running this again. If I do this, notice that it's actually serving from my container, which is actually good. Now that we know that the image is is correct, we will now push it to Docker. But before I do that, let me kill this. Let me kill this image first. Okay, so I will push the two images. I'm pushing it to here. Pushing it to here. Okay, so that's the first image. Oh, right. I need to delete this. This I was actually doing some tests. This one. So let me delete these things first. So the settings. Okay, so let me delete these two images first. This is the old one. Let me see, a few seconds ago. So just delete those two images first. So this one, and now I'll push the other one. Okay, so both of these images are up here. So now you can start using this image. You can either, if you have a Docker host, you can push it to the Docker host and use it. But in our case now, we want to take it one step further, and what we will do is this: we will run it, we will deploy into, use it in a Kubernetes cluster. I am using Minikube, and I've set up my Minikube to be like, this is the setup of my Minikube. So I've used 8192 Mac, 4 CPUs, and I've enabled the network plugin. I've installed Cilium. You can find the instructions here. I've also enabled the Metal Load Balancer add-on. You need to configure the Metal Load Balancer because the Metal Load Balancer will, simulate, allocating IP address to load balancer. I'll talk more about this a little bit in a little bit. If you have any questions, you can put it in the comment below. And then I will also enable Ingress, right? And I've also enabled metric server, but we won't be using metrics server here. Oh, this is incorrect. Okay. Enable metric server. You can list the add-ons, and then you can verify the Ingress and the Metal LT. So let's have a look at these two first. Minikube add-ons list. I've enabled Ingress, Metal Load Balancer, the Metal Load Balancer, the metric server, which we won't be using. Also, we can look at this kubectl So you can see that this is the Cilium, the network plugin, and this is the Ingress, okay, and the Metal LB is under here, okay, and also the metal load balancer will allocate IP address from this range of IP address. Okay. By the way, the Minikube. Let me just do that again first. Minikube. My Minikube's IP address is this. So this last one, but the metal load balancer will not allocate this address. So let me show you what I mean by this. The architecture that we are going to deploy is this. Let me make this bigger so you can have a look at it. These are our containers. We're going to deploy them as pod. We're going to create what is called a deployment. The deployment will control how many instances or applications running. So I mean, ours is a really simple web application, so it doesn't really need that many. But in case if you're running like a full stack application, like a backend Express or a Java application, you may need more than one copy of this. The deployment creates something called a replica set. You don't have to create replica set directly. You create a deployment. In a deployment, we'll say things like how many replicas that we want. Okay, and then after you have done that, we will create a service to access this. Okay, there are two. We'll look at two types of services. One is the load balancer, which will actually provision a load balancer. If you're running this in your cloud provider, for example, like if I were to run this on DigitalOcean, when I provision a load balance, a service type of load balancer, it will go off and provision a load balancer. Okay, and then the second type of the second type of access that we're going to see. So that's the first type of access. Second type of access that we're going to see is we're going to use an ingress controller, and I'll talk briefly about the difference between these two. The entire application is deployed inside a namespace. So I'll call this namespace neat. Okay, these are the various names of my deployment. So let's start off by creating a namespace. These are the namespace, right? These are the default namespace. I'll create a namespace. I'll call it neat as here. You can get a namespace. So my namespace is there. Now I will go and create the Kubernetes deployment. Let me call this front end YAML. We'll start off with creating a deployment. The deployment will say how many instances we want. By the way, let's have a look at the Kubernetes documentation. Okay. Right, so we will go, this is the one that we're going to use, deployment. Okay, so we will say API version apps, that's the resource group, and we'll say version 1, the kind is deployment, and then the metadata, the name, I will call this fe. So I'm going to follow this thing. Okay, I'll call it fe deploy, and then the labels, I'll put the same thing again, fe deploy, and then the spec here, replicas, I'll say 2, and then I will say the selector. Okay, I'll explain this a little while. So let me just leave this blank here first. Now I'll specify the template. The template says, what is the actual deployment. Okay, the template mirrors, is actually a pod specification. So it's the same, it's metadata. The name here is going to be, I'm going to call it fe pod, and then the labels, I'll call it app fe pod. Okay. So this selector here, this match labels here, this, okay, let me just change back the name. Okay, so this match labels here selects the port, selects the port. Basically what it's saying is that so what we are saying is this, how does a deployment knows which port belongs to it? And the way it knows which port belongs to it is by looking at the labels at the port, at the labels of the port. Okay, so this is what it is. This is the label of the port. So we are saying any labels, any port with this label belongs to this deployment, and we can only have 2 of this replica. If I have more, if I have one more, then the deployment will attempt to kill the port. It will only allow two replicas. If there is one port running, then the deployment will start another port. If there is more than 2 ports, the deployment will bring the number of replicas back down to 2. Now we will do the same thing. We'll say spec. Okay, we'll define spec, and then we'll say containers. So a pod is like a number of P's in a pod, right? So a container is like a P in a pod. You can have X number of containers in a pod. In our case, we're only going to have one container. We need to give the container a name. Call this fe container, and then the image. The image is going to be this guy here. That's why we need to push it. It's going to be this. Sorry, it's going to be this guy. Okay, this guy. That's why we need to push it because Kubernetes is going to pull from this public repository. So the image is this, and then it's called init stack, and then it's v1. Right, so I'm pulling v1 image. Image pull policy says, what should you do with the image, right? There is a few of them. There's if not present. I like to type this. The default, I think is if not present. What this is saying is if the image is not inside Kubernetes, you should pull it. Okay? The other option is always. So I'm going to not. Okay. We don't have, since it's a very simple image. There is no volume mounts, or there are no other environment variables to set. The last thing we're going to say here is what are the ports that the container is exposing. Okay. So as we know, I'm going to give this. As you know, the container port is 8080, right? So let's go back to here. Oops. Let's go back to our Docker file. Okay, the 8080 is this 8080. Okay, which is also this 8080. Okay, so that's our deployment. Let's deploy this guy. Apply, and then run this in the neat namespace. What's the namespace? Neat. Okay, so kubectl apply the name of the file and put it into a neat namespace. Right. So let's have a look at this one. Okay, so the container is creating. That's the deployment. The deployment creates a replica set. So notice that there are 2 deployments here. Okay, we can actually test our deployment by doing something called a port forward. Same concept. Kubectl port forward, and then we will forward our deployment. We say fe deploy. That's the name of my deployment, and then we will forward. So remember, the deployment is 8080. So let me just say this is 5000 to 8080. You can find it in the neat namespace. Okay, and then we can test it again. Okay, so this is 5000. I notice that when I connect, notice that the connection is coming in. I can actually delete this first, just to make sure that we are not pulling from, we are not connecting from local host. Apps. So let's reload this again. Notice that the connection, we are actually getting this from our Kubernetes cluster. okay, and not running it from, and not being served from cache. Okay, so we have got this part here. Okay. Now we need to create a service. The idea of a service is so that there is a uh, that, uh, there is a stable IP address that we can connect to, and then the service will do a simple dispatching to any one of these ports. So let's create a service. Okay, so we'll say API version v1 kind is a service, label metadata, the name call this fe service. Say name fe service, call it svc. Okay, and then the spec, the type is going to be a load balancer. The first one, we're going to do two of them. The first one is going to be a load balancer. Okay. The second one, same concept. We need to provide a selector to let the service know which are the ports, when you receive a traffic, which are the port it should route the traffic to. Okay, so the load balancer is a reverse proxy. Okay, so same thing. It's going to be fe port. Notice that for deployment, you say you have selector and then match labels, but for service, it's just selector and the name of the label. Okay, that's service, and then we will say, and then we will say ports. What are the ports that's going to be exposed by this service? Let me give a name to this service. Okay, the port is going to expose is AT, and the target port that is going to be mapped to is the FE port. Right, so we are mapping port 80 to port 80. So this name, FE port, is this name. If you don't have, the name here is optional, you don't need to put the name. If you do have the name, then you can use the name. Otherwise, you need to type the number. Right? Let's deploy this guy. Okay, remember that this is a load balancer. So now if I go to my service, you'll notice that the service is enabled. And now I have a load balancer. This is the external IP of the load balancer. This is the cluster IP, the internal IP, and this is the external IP. If I were to deploy this in DigitalOcean, what DigitalOcean will do is, at this point, is this: the CCM, the cloud control the cloud controller manager in Kubernetes will deploy a load balancer, a DigitalOcean load balancer. Okay, so this is the IP address. In this case, this is a simulation because this is what the metal load balancer is doing. I can now come to here, paste this here, and I will get this. Notice that there is no service worker. The reason is because besides localhost, any other IP address you need to have a certificate installed, SSL installed, right? So if you go to storage again, you also notice that it will not cache anything. Okay? So in this case, if I don't install a certificate with my load balancer, then I will not get I will not get the progressive web app. Okay, so you might not actually want to do this. You might not actually want to expose a service directly as a load balancer. The reason is because every time when you expose a service as a load balancer, at least on DigitalOcean anyway, it will provision another load balancer, right? So this load balancer, cost money, right? And the load balancer are pretty powerful, and we are deploying behind a very simple, web, web server, right? So the load balancer is actually very, very, very capable. What we would ideally like to do is this: we would like to deploy one load balancer and then have that load balancer, balance the traffic or route traffic according to host name and path to different backend services. Okay, this is where the Ingress comes in. Okay? What Ingress allows you to do is this: Ingress allows you to, when you deploy an Ingress into Kubernetes, the the controller, the ingress controller will provision one load balancer, and then you can now configure the ingress based on either the IP address, based on the domain name or the path or both, right? And then the ingress will route the traffic according to what you've defined to the different services. So think of ingress, like your caddy or your Nginx, where the back ends are your upstreams. Okay. So to do that, what we need to do is this. I will first of all delete the service first. Delete the service -n, and then what I'll do is this. I will delete this guy, right? Now, to use the ingress, what we'll do is that we'll convert this, we'll change the service type from a load balancer to a cluster IP. Okay. Now we will define an ingress rule. So the ingress rule is API version networking K8SIO and v1 beta 1. Okay, so let me just check this is correct. This is ingress, so that is v1 beta 1. Okay, let me move this up a little bit, and then the kind is ingress. Okay, the metadata, the name, I'll call this FEING, and then labels. Name, I'll call this FEING. So the specification, I don't use this that much, so I need to look at it. Right. So the specification, what we need to do is this. We need to give the ingress class name. If your Kubernetes cluster has more than one ingress controller, you need to give the class name. In my case, there's only one ingress controller. I don't need to give, but I'll just do it here for completeness sake. And you also need to know the name of the ingress class. My case, the ingress class name is called Nginx. Ingress class name, Nginx. And then we'll specify the rules, right? The rules are the host. So what I'm going to do is this, right? I'm going to create a fake host here. Okay, so what I'm going to do is this. I'm going to use a service called NIPIO, which allows me to map like fake domain names into the actual into the actual IP address. What I'm going to do is this. I'm going to take this minikube, here. I'm going to say this. I'm going to say front end NIPIO. So this one will get resolved into when I type this into the browser, you'll get resolved into the 192.168.39.106, right? And then I'll specify the different path. So path slash, right? So this is one domain. Okay. All paths should map to the following backend. The service name is FESVC. The service port is FESVC port. The ingress exposes port 80. So when it receives HTTP request coming into port 80, you look at the host attribute. So this is defined in the host attribute, right? Host attribute, and then looking at the host attribute, it will route the traffic to this service. Okay, so that's my ingress. Let's apply this guy. Let me just check if I have converted this into cluster IP. Yes, I've converted it into cluster IP. So let's apply this guy. And you'll notice now that the ingress is enabled. The class is Nginx. We'll wait for a while for this to, it will come up the IP address of the external port will come up. But since I already know what it is, so I don't have to really worry about it. Now go back here and paste this here, and you notice that this one gets routed to here through the ingress. If I just type the IP address like that, I will get this error because there is no host mapped to this 190, 192, 168. Okay. Also notice that there is no service worker running, and the reason is because the ingress is not doesn't have SSL. Okay, so you can either so there are two ways of deploying SSL. If you want to, you can either deploy the SSL here at the load balancer, okay, in case of ingress, or you can apply SSL per base per how should I say per per host. Okay, so we can try applying this. We can try creating an SSL and applying it to this host. What we'll do is this: we will generate a fake, a self-signed certificate. So let's go and do that. Open SSL. We will, I'm just showing you how to do it in case you are running a hosting service for for others. We will create a key first. Gen RSA. We'll say out. Let's call this fe.key. Let's 4096. Okay, so I've got that key. Then the next thing I want to do is I want to generate a signing request. And then the subject. So the subject, the name must be this guy here. So that's the CSR. Let's have a look at the CSR. And then we'll say out. Sorry, text. No out. Okay. So the important thing to get correct is the name. Right. So now we can sign this. By the way, I'm going to use my Minikube key, my Minikube CA key, which is here. Okay, the CA cert and the CA. Where's the CA key? The CA key. Okay, so open SSL X509. We press new. Underneath. Maybe Stack Overflow is better. Okay, in is in which we call what was that called? FECSR out FECRT CA. I'll say Minikube CA. This is cert, and then CA key. Minikube CA key, and then CA create serial. Okay, see if this is correct. Yep. So we got the key. That would be the CRT. So let's have a look at that again. We say in FECRT text no out. So that's signed with the Minikube CA. Okay, you can sign with your own CA. I can also do it self-signed, but since I've got a Minikube CA, I'll just use the Minikube CA. Where's my subject? My subject. That's the subject. So this is very important to get right. Otherwise, we will not be able to do. We will not be able to set the the certificate to our ingress. Okay, right. So now what we need to do is that we need to create a secret, a TLS secret, and then after a secret is basically a way of creating some configuration information in your Kubernetes cluster. Okay, so let's look at our file again. These are the two files. Let me delete the CSR. Okay, and I'm left with the two files. Now I'll create a secret. And the secret is TLS secret. I think it's called key, which is the fe.key, and then the cert, which is the fe.crt, and I'll create it in the need namespace. Oh, I need to give a name. Okay, so let me give it a name. Let me call this fe secret, TLS secret. Okay, right. So that's been created. We can look at it by doing cube ctl get minus n need. Oops. Oh no, secret. Right. So that's our secret here. We can do a describe. That's our secret. So the name of our secret is FETLS secret. Now all we need to do is just go back to here. Go TLS. Let's go back to my ingress. I can't remember this. TLS. So it's an array. The host is this guy. Okay, and the secret name. The secret name is FETLS secret. Right? FETLS secret. Okay. So let me just check again. So secret name. Now we can recreate this thing, reapply this. Oops. And then field host. Host. Sorry. Host. Just like this. Okay. So these are the list of hosts that uses this secret. That's basically what I said. Okay. Right. So now we can go back here and have a look. Now notice that now there is port 443. We can now use HTTPS. And of course, ours is a fake self-signed certificate. We can have a look at this certificate. Make this. If you look at the certificate, we will view certificate. So that's our certificate, right? Okay, we are okay with it. We can accept and continue. Right. So that's the application now. Notice that it is secure. It's HTTPS now, and notice that we have got our service worker, and also we have cached the data. Let me just run this again one more time. Okay, now notice that we have cached the data. Okay, so that's the end of this episode, which I've showed you how to build how to build an image and how to deploy it into Kubernetes. In the next episode in this season 1, I'll show you how to build a standalone binary, packaging your this application into the binary so that you can distribute the entire application, as one binary. You don't have to use like caddy, or you have to build a container. This is for like desktop application. You're running it directly on a server. So that will be the next episode. Okay. Until then, stay safe, and I'll see you the next time.